All right, this is Mr. Wyrick, and I'm going to go through some of the stuff here on the review. It says start by writing the formula for area of regular polygons. That's area is equal to 1/2 times the apothem times the perimeter. Going to be pretty important for that. And volume for a prism, volume is equal to the area of the base times the height. So if we have a regular polygon, we're using this for our area. That will be the area of the base. Then we multiply that by the height. Find the area of a regular hexagon with an apothem of 8.7, sides that are 10. So that's going to be 1/2 times 8.7. And then we're going to multiply that. A hexagon has 6 sides, 10 centimeters apiece. So that's times 60. So here on my fancy calculator, I'm going 1/2 times 8.7 times 60. And I come up with 261. So this is 261 square centimeters. Label is important. Find the area of a regular octagon with an apothem of 4.8 and sides of 4. So that's 1/2 times 4.8. And then we're going to multiply that. 8 times 4 is 32. So we're going to come up with 76.8, and that should be square inches. What is the measure of one interior angle of a regular hexagon? This is n minus 2 times 180 divided by n, and the n in this case for a hexagon is 6. So 180 divided by 6 is 30. 30 times 4, that's going to be 120. What is the measure of one interior angle of a regular pentagon? Again, this is 180 times n minus 2 over n, and this is 5 here. So 180 divided by 5 is going to be 36, and 36 times 3 is 108. Find the apothem of a hexagon with side lengths of 6 feet. So we've got the hexagon. That's a decent hexagon there. Every side is 6 feet, and we're going to make this triangle here, and when we do that, this is going to be 6. We already know that the angle is 120, so this is going to be a 60-degree angle. I'm going to stop there because this is a 30, 60, 90 right triangle that I'm looking at. So I know that if this is 6, this small part here is going to be 3. So this is 3 square root of 3. If I'm working this out with the sine, cosine, tangent stuff, then this is going to be the tangent of that 60-degree angle is equal to my opposite side that I don't know over my adjacent side of 3. So I would do 3 times the tangent of 60. 3 times the tangent of 60. Hope I'm in degree mode. Doesn't look like I am. And I forget how to do that on this one. So, yeah, I'm going to leave that one as 3 square root of 3. Actually, I can type that in. So we should be around 5.20 for this when you round it to 2 decimal places. Find the apothem of a decagon with side lengths of 12 feet. So I'm going to run into trouble here. Gonna need to find the settings there. There we go. Got that changed to degree mode, so that'll help. So find the apothem of a decagon. Decagon's going to have 10 sides. I don't think I can really draw that one. So we got the triangle we got right here. The regular side is 12 feet, so this is going to be 6 feet. And we're here like this. We go back up here to figure out how much this is going to be. So 12 minus 2 is 10, so that's 1,800 divided by 12. That gives us 150. So we have 150 degrees for the interior angles, meaning this one's going to be 75. So this should be 6 times the tangent of 75. And we get 22.3 9. When we round to 2 decimal places, that's our apothem. That's all we have to figure out there. On number 7, find the perimeter of a pentagon with an apothem of 6.2. Again, we're looking at that triangle. It's looking like this. This is 6.2 here. We're still using tangent. This is going to be a 54-degree angle. But this time, the tangent of 54 is equal to the side that we know is the opposite, that 6.2, over the adjacent side of x. So we're going to swap these. This is going to be 6.2 over the tangent of 54 is going to give me this x side right here. So 6.2 divided by the tangent of 54. And we come up with 4.50. So if this is 4.50, that means that the entire side is going to be 9. And this is a pentagon, so 9 times 5 means we should be at 45 for the entire perimeter. Perimeter of a nonagon, again, we're going to have this same triangle. The apothem this time is 5. 180 times 7 divided by 9 is going to give us a 140-degree angle, meaning this is 70 here, this one's 20, just in case you want to do that. But we have this, we're looking for this one over here, and this is our right angle. So this is the hypotenuse. We don't have the hypotenuse, we're not looking for the hypotenuse. This is tangent again. The tangent of 70 is equal to 5 over x. So we're going to do 5 over the tangent of 70. So we get 1.82. And if that's 1.82, we're going to multiply that by 2. That's going to give us 3.64 for the entire side. And this is a nonagon, so we're going to multiply that by 9. We get 32.76 for our perimeter on that one. The volume of this figure, we have 1/2 of the apothem times the perimeter, and then we're going to multiply that by the height. So this is 1/2 times 7 times my perimeter here is going to be 50, and then we multiply that by 11. So 1/2 times 7 times 50 times 11 is going to give us 1,925. This is volume, so it's cubic centimeters. Hexagon with side lengths of 12 forms the base of a prism with a height of 15. What would be the volume? So again, we got to kind of go back. Side lengths of 12, which means when we do this, this is going to be 6. This is going to be 6 square root of 3, because hexagon, if you were doing this numbers-wise, this should be an apothem of 10.39, I think. Let's check. That's going to be 6 times the tangent of 60. Yeah, 10.39. Okay, so we have an apothem of 10.39. So we go 1/2 times our apothem of 10.39 times our perimeter of 72, and then we multiply that by the height of 15. So 1/2 times 10.39 times 72 times 15 is going to give us 5,610.6, and that's going to be, it doesn't give us a measurement, so units cubed. Okay? 2 cubes exist. One has side lengths of 6, the other one has side lengths of 24. What is the ratio of the sides? If we go 6 over 24, that's going to reduce down to 1 out of every 4. What is the ratio of the surface areas? Well, a single side of this one is going to have an area of 36, and there's 6 sides there that are all the same. So that should be 216 for the surface area. And then on this one, we have 24 times 24. That gives us 576. We multiply that by 6, so we have 3,456. Now, we could try to reduce this fraction, but you really don't have to, because we just need to take this one and square it to get a ratio of areas. So 1 squared is 1, 4 squared is 216. Okay, if we try that out, 216 divided by 3,456, it should reduce that, yeah, down to 1/16. So we don't even have to work too hard there. And then what would be the ratio of volumes? 6 times 6 times 6 is again 216. And then 24 times 24 times 24, or 24 cubed, is going to be 13,824. And again, we can reduce that if we really need to, but we shouldn't have to. We should be able to just cube this instead of squaring it for the volume. 1 cubed is 1. 4 cubed is going to be 64. So that's the ratio of our volumes, is 1/64. If we type it in, we've got 216 divided by 13,824. And sure enough, that reduces down to 1/64. Hopefully this gets you everything you need for the test tomorrow. Good luck.